Good morning to everyone. My name is Muhammad Qais Qayyum bin Muhammad Zabri and my matric number is 01DDT23F1097. Today we will present a mini project course DFC30233 data structure. This mini project will present by myself, Amino Anip bin Jalih, 01DDT23F1049, and Muhammad Izzuddin bin Muhammad Anwar, 01DDT23F1187. For a table of content, question 1 will be presented by myself, question 2 and 3 will be presented by Izzuddin, and lastly question 4 will be presented by Anik. Now we will go to the first question. The question is, Aiman joined a programming competition in his faculty. He has given 1 week to solve a problem. Aiman asked for your help to construct a program to reverse the word that enter the program. For example, if users enter ALI, the output will display ILA on the screen. Aiman wants you to use stack to store the inputs. To create stack and input string, stack jar stack will create an empty stack to hold the characters. String input will create a string to store the word entered by the users. To ask user for a word and store it, type cout enter a word. It will display a message asking for the users to type a word. Cin input will store the user's word in input. To push each character to the stack, type for char character ch input. It will goes through each character in the word. Next, char stack dot push character adds each character to the stacks one by one. To print each characters in reverse order, type cout reverse orders. It will display a message before showing the reverse word. While char stack.empty runs as long as there are characters in the stack. Next, char stack.top will show the top character, which is last entered added. To cout, char stack.top will print the character. For the last, char stack.pop will remove the top character, so the next one become the new top character. This repeats, printing each letters in reverse. For the display, if user enter the word ALI, the output will become ILA. Now, I will pass to my friend to continue this presentation. Thank you.
Assalamualaikum and good morning to Puan Mageswari. My name is Muhammad Izzuddin bin Muhammad Anwar. My matrix number is 01DDT23F1187 and I'm going to present the solution for the question 2 and question 3. First of all, let's take a look at question 2. You are hired to develop a food ordering system for XYZ restaurant. The system should use first in, first out FIFO concept to manage food orders. When a customer places an order, it gets added to a stack of orders in the kitchen. To handle the orders, you decided to use a queue linked list data structure, where each node in the linked list contains a stack of orders for one customer. As cooks complete each order, they pop it off the stack, display it on the screen and prepare it for delivery to the customer. Write a C++ program to stimulate the process. Now let's take a look at the coding solution. Now because the whole coding itself is very long, I'm going to break it down in 8 parts. Now let's take a look at the first part. The first part is including library. Now as we can see, we have 4 include, which is include IOStream, include stack, include queue, and include string. Now these libraries, it let us use standard input output IOStream, stacks, queues, and strings. The second part is order node structure. It defines a structure for each customer's order, where each order node has these two things. The first one is orders. Orders is a stack holding the customer's orders, while next is a pointer to the next order node, linking each customer in a queue. The third part is order queue class. This one, it defines the queue which manages customer orders. The front points to the first customer in the queue, while the rear points to the last customer in the queue. The fourth part is order queue class. This one, it initializes front and rear as null pointer, making an empty queue. The fifth part is enqueue function. This one, it adds a new customer and their orders to the queue. It creates a new order node with customer orders. If the queue is empty, the rear is null pointer. It sets both front and rear to this new node. Otherwise, it adds the new node at the end and updates the rear. The sixth part is the queue function. This one, it processes and removes the first customer in the queue. It checks if the queue is empty, and then it pops and displays each order from the customer stack until it is empty. And then it moves front to the next customer and updates rear to null pointer if the queue becomes empty. And then it deletes the processed customer's node. The seventh part is empty function. This one, it returns true if the queue is empty. Otherwise, it is false. And the last one is the main function. This one, it creates an order queue object, and then it defines two stacks of order, one for each customer. And then it adds each customer's order stack to the queue with enqueue. And then it processes all customers in the queue by calling the queue repeatedly until the queue is empty. And this is our output. Now, for each sentence of customer order added to the queue, it refers to one customer. And as we can see, for the processing orders for a customer, it refers to what a customer is ordered. As we can see, for the first customer, he or she order an orange juice, a fried noodles, and a fried rice. While for the second customer, he or she orders a watermelon juice, a porridge, and a fried chicken. And that is all for question 2. Now let's take a look at question 3. Write a C++ program to show the implementation of binary search tree using linked list. Your program must include basic operations in binary search tree, including creating BST, inserting item into BST, deleting item from BST, and display data in BST. Now let's take a look at the solution. Now because the whole coding solution is very long, I'm going to break it down in 8 parts. Let's start with the first part, which is the node structure definition. It defines the structure of each node in the binary search tree. Data stores the integer value of the node, left pointer to the left child node, or null pointer if there is none, right pointer to the right child node, or null pointer if there is none. The second part is function to create a new node. It creates a new node with a specified value and no children. The first step is it allocates memory for a new node. The second step is it sets the data field to value. The third step is it initializes left and right to null pointer, indicating no children. And the last step is it returns the newly created node. The third part is function to insert a node into the BST. It inserts a value into the BST while maintaining the BST property. The first step is if root is null pointer, we are at an empty spot, so we create and return a new node. The second step is if value is less than root data, we recursively insert into the left subtree. The third step is if value is greater than root data, we recursively insert into the right subtree. And the last step is after the insert, returns the root node, updated if necessary. The fourth part is function to find the minimum mode. It finds the node with the minimum value in a subtree used in the delete operation. The first step is it traverses the left subtree until reaching the leftmost node, which has the minimum value. The last step is it returns that leftmost node. The fifth part is function to delete a node from the BST. It deletes a specified value from the BST for the first step is if value is less than root data, it searches in the left subtree. The second step is if value is greater than root data, it searches in the right subtree. When it finds the node to delete, for the first case, if the node has no children, it deletes it and returns null pointer. For the second case, if the node has one child, it deletes it and links the child to the parent. For the third case, if the node has two children, it finds the minimum node in the right subtree to replace the node's value, then deletes the minimum node from the right subtree. The sixth part is function for in-order traversal. It displays the BXT nodes in ascending order. The first step is it recursively visits the left subtree, prints the current node's data, and then visits the right subtree. The second step is it displays each node's data as it's visited, producing a sorted order for BXT. For the last part is main function for menu and operations. It provides a menu-driven interface to the user for BXT operations. The first step is the only step is it displays a menu with option for it displays a menu with options for inserting, deleting, displaying, and exiting. Based on the user's choice, the first choice is it inserts a value using insert. The second one is it deletes a value using delete node. The third is it displays all values using in-order traversal. And the last one is it exits the loop when the user chooses option 4. And these are the output, and these are the example of the output. So the first output is insert value 9, and then we insert the second value, which is value 8, and the third one is we insert value 7, and then the fourth one is we display all the inserted value, which is the 7, 8, 9 in the ascending order. And then the fifth one is it deletes the value 9, as we can see, and the sixth one is it display all the value after deletion of value 9. As we can see, it is still display in the ascending order. And the last one is exiting the program by choosing the fourth option. And that is all for question 3. I will pass the presentation to my other partner. That is all from me. Thank you.
Hello everyone, my name is Aminur Anid bin Jalil. My matrix number 01GDT23F1049. I from class DDTN 3B. Our lecturer name Puan Magiswari. So today I will proceed to question 4. So before we proceed to the question 4, I will tell to you guys about linear search. So what is linear search? Linear search is a simple searching technique that involves checking each element in a list one by one until the desired element is found or the end of the list is reached. So how it works? It starts at the first element of the array or list, then compare the current element with the target, and then if the current element matches the target, the search is successful. So that if not, move to the next element and repeat. And then lastly, if the end of the list is reached without finding the target, the search is failed. So we proceed to the question and we will explain how to answer the question. So based on figure below, illustrate the step to find the target key. So the target key is 52. So the first thing you need to do is you need to start with index 1. Index 0. So their data is 8. So 8 is not equal to 52. Moving to the next step, step 2. Index 1. Index 1 data is 11. 11 is not equal to 52. And moving to the step 3, index 2. Index 2, their data is 19. So 19 is not equal to 52. Step 4, index 3, their data is 25. So 25 is not equal to 52. Then step 5, index 4. Index 4 is 34. So 34 is not equal to 52. step 6, index 5. Index 5 data is 47. So it is not equal to 52. Moving to the last step, step 7, index 6. Index 6 is 52. So 52 is equal to 52. So it match. So the target key is found at the index 6. So we will proceed to the binary search method. So what is binary search? Binary search is an efficient searching technique that works by repeatedly dividing a sorted array into half to find the target element. It is faster than linear search but requires the array to be sorted. So how it works? It starts with the entire array and find the middle element. Compare the middle element with the target. If the middle element matches the target, the search is successful. If the target is smaller than the middle element, search in the left half of the array. So that if the target is larger than the middle element, search is in the right half of the array. Lastly, repeat this process until the target is found or the sub-array become empty. So we will answer the question with the binary search method. The same question 4. So the first step you need to do is you need to find the first index and last index. So based on the question, 0 plus 9. After that, you need to divide to 2, and the value that you get is 4.5. If you get the 4.5, you need to take the left value, which is 4. So the median is 4. So their data is 34. After that, 52 is bigger than 34. So moving to the step 2. After we found the median at the first step, which is 4, and the value is 52 bigger than 34, you need to take the right side, which is index 5. So the index 5 is the meaning of index 5 is the first index, and the last index is same 9. So you need to do the same thing, 5 plus 9 and divide to 2, and then you get 7. Index 7 data is 55. So 52 smaller than 55. Moving to the next step, you will get their last index is 6, because before this you get 52 smaller than 55. So it means it will go to the left index. So the first index is same 5, and you need to plus 6, which is last index, and divide to 2. You will get 5.5. And like I said before, you need to take the left value, which is 5. So index 5 is, their data is 47. So 52 biggest than 47. So proceed to the last step. Their first and last index is same, which is 6. 6 plus 6 plus 2, their value is 6. So their index is 52. So it makes the target key 52 is equal to 52. That's all from me. Thank you.